Hello guys, welcome back to another lecture in this course. In this video, we shall be looking into decision tree classifiers. So in supervised learning algorithms, we have a decision tree classifier, which is a class capable of performing multiple class classification on a dataset. And it is nothing but just a flowchart which can help you make decisions based on a previous experience. And to make a decision tree, all data has to be numerical. And if not, you have to convert that data to make sure that all the data available, it's a numerical data. For example, when we were analyzing this data of students' performance, we needed to change, for example, if you are checking parental level of education, bachelor's degree or some college, maybe with a master's, we can say it is 1, or we can say it is 0. With some college, we can say it is 1. Then degree, you just have to convert this string to a numerical data type. So when you're analyzing the data in a decision tree, you have to make sure that all data is in numerical data type. So now also, a decision tree classifier takes two inputs, takes the iris features or the iris variables as our X, meaning this the data in our iris, and the target is our y, which is the dependent variable. So you can so here what we need to do also, we need to install graph this from conda by simply typing conda install python _ graph viz. So what we can do here, we need to install this module. Let us just go here. Let me click Windows button. Then on my Anaconda, let me go on Anaconda prompt. Okay, let me push it here. Okay, then, and you can also use pip install. So let us install this one. Okay, so let us just type pip install graph. Then we press enter. So if you have already installed this program, or it is already satisfied, the interpreter or the command prompt will tell you, give you feedback. Okay, in this case, you can see that I have already satisfied. I've already installed this library or this module there, and also I've said that you can use conda. So to use conda, you just say conda install python -graph this, just like this. Then you press enter. Okay, there's an error on conda. I said conda, so let's say conda install python -graph is okay. Press enter. So if the library is already there or the module is already there, the system will tell you that this is already satisfied. So if it is not there, we can actually see that it is installing. So here you just press Y to say yes. Then the installation will proceed, and the execution also will proceed. Okay, now we are done installing. So these are the two ways, either conda install or pip install. So after installing this, what we need to do now, we need to import our dataset from sklearn, and also we need to import our decision tree classifier from the tree module in our sklearn library. So now let us load our dataset, which is iris that we are going to use, and our variable here, which is x, we are going to call the data, and our target, which is the y or the dependent variable, which is our target, and we want to create a decision tree classifier for this data. And the decision tree variable here that we have created, we are going to put a random state of 0, and we want to train the model by using our decision tree here. So decision tree that we have created here, and we have stored it, the model, we have stored the classifier in this variable, stored the classifier in this variable. Now we need to make sure that our model fits in of this variable that we are having, the features and the target, the x and the y. Now let us make a new observation. So our new observation that we are making is having only the following elements 5, 4, 3 and 2. So predict observations class. So we are going to run our line of code here. The prediction, we get an output of 1, and it means that the classifier is predicting that the flower here, the flower is predicting that the flower is Iris setosa. So the decision tree now is trained to predict the class with the highest probability. So we are going to make sure that the class with the highest probability is Iris setosa. So in this case, the probability that the flower is Iris setosa is higher than the probability that the iris is vesicaler or virginica. So we can actually say that 0.5 array output means it. So in other cases, probably you might get a 0.5 output, which means that it is equally likely to be any of the 3 flowers, either setosa, virginica, or vesicaler. Here, to view the predicted class probability for the 3 classes, here we just say model.predict probability of our observation. You can just see that we have 0, we have 1 and 0. And remember, we have only 3 species. We have the setosa, virginica, and vesicaler. So now what we need to do now, to visualize a decision tree, what we need to do first, let us import the pi.plus module or library. If you don't have, let us go here on our Anaconda prompt. Then let's say pip install pi.plus module. Press enter. So we need to import this module if you don't have. So just type pip install pi.plus. So we can see that the requirement already satisfied. It means I already have this module here. So if you don't have, you install. So now also we need to import our decision tree classifier in the tree module in our scikit-learn library. Then we call our dataset, and also we need to visualize as an image, or then we convert maybe to a PDF or something. So we need IPython so that we be able to display the image here. And also we have already imported the tree. Now here we load our dataset. Okay, since we have already loaded our dataset previously, and here we are just doing repetition on creating the decision tree classifier of our object with the random state 0 here, and we store it here. Then we train our model for x and for y, which is features and the target. For the features, these are just the sepal, the petal, and these are just the sepal width and sepal length, petal length, and the petal width. Then here now we create the dot data. So the dot data here, we are taking our tree that we want to visualize, tree dot export our graph viz that we have created above, that we have installed in the library. Then we need the decision tree here for the model that we have created, the decision tree classifier here of this data here that we have classified, and our out underscore file equals to another parameter. Then here, so these are the feature names and also the class underscore names, meaning the target here. Then we need now here to draw the graph. So these are just the parameters that we are having for our tree. Now to draw the graph, now we are creating a variable graph. Then we call our module py.class.graph underscore from the dot underscore from underscore dot data. Then we call the dot underscore data, this here, in which this we have these variables which contain the data that we want to plot here. Then now we visualize our graph as an image here, as you can see. So let us run our line of code. Right, as you can see here, this is our decision tree. As you can see, we said the probability is setosa is very high, and we have actually explained it here, as you can see here, that there is a high probability that the flower is setosa by getting this result here. So now on our decision tree, we can see that we have setosa here. So how we explain here, we can actually see that we have petal width less than or equals to 0.8. We have Gini, which is 0.667, samples 150, values we have 50, 50, 50, and the class is equals to setosa. Then true here, then we get Gini 00, samples 50, then it goes on and on, then it comes on this side where it is false, and with false we can see that there is a versicolor, and the samples now they have reduced it from 150, they are now 100, and also values, they've now 0, 50, 50, and it goes on this side, and we can see now the petal length which are less than or equal to 4.5, and here now -1, we are having 54. Same applies to this side also, we are having 46 and 0, 1, 1. So what is actually going on there, it is actually explained and summarized here, where we are saying the petal width of less than or equals to 0.8 or lower will follow to true, and the rest will go for false with the false to the right. As you can see here, this is what actually happened. The petal length which is less or equals to 0.8, it goes here to true. So this is the data which actually goes to this side and for setosa, and the rest goes to false. And also Gini, the Gini refers to the quality of the split and is also between 0 and 0.5. So 0.0 and 0.5, where 0.0 means all of the samples got the same result, but 0.5 would mean that the split is done exactly in the middle. So this is just the Gini, and also these are samples. Samples is equals to 1, mean that there are there is only one observation listed at this point in the decision. So the value we have 0, 5, 0. It actually means that we have 50, 50. For example, at the initial here, at the initial stage, we have 50 setosa, 50 versicolor, and 50 also virginica. These all were 50 to accumulate to a sample of 150. But after the decision is made, it means some deduction was made, and the 50 samples goes to this side, and another 100 goes to this side, where the other is versicolor and the other is virginica. And the decision continues, and you can see as the decision move forward, the samples are continually decreasing, and the numbers of elements are also decreasing up until we get 0, 0, and here you can actually see what is going on. So this is how we make a decision using a decision tree. I think this is all for this lesson. See you on the next lecture. Bye-bye.